All right, we are continuing in section 7.2, where we're talking about inverse functions. And we talked about last time how we could see those inverse functions in a graph, but now we want to know how can we verify that these functions are actually inverses of each other, besides looking at the graph like we did in the last video. So if f is composed with g of x, and that equals g composed of f of x, and that equals x, then we can say that f and g are inverses. And so we can also see it in the box here, we can see it written both ways, where we have f of g of x equals g of f of x equals x. So we need to do a composition of functions, like we talked about earlier in this module. So to do that, we are looking here and it tells us that we need to put our g of x into our f function. So we're going to take this x plus 2 all divided by 3, and we're going to put it in place of x here. So when I do that, I have 3 times x plus 2 divided by 3, and then I'll subtract off 2. So if I simplify this, let's see what happens here. Well, this is really 3 over 1, and so I can see that those 3's will divide out, and then that's going to leave me with x plus 2 and then minus 2. Well, the plus 2 and the minus 2 zero out, and we're left with just x. All right, so we're off to a good start. We can see that one direction, this f of g of x is x, but now we've got to check the other way. See if g of f of x also equals x. So that means this time we're going to put 3x minus 2 in place of x. So when we do that, we have 3x minus 2, and then plus 2, all divided by 3. So now when we simplify this, well, we can see that negative 2 plus 2, that zeroes out, and that leaves us with 3x over 3. And now those divide out as well. 3 divided by 3 is 1. And so that means I am left with just a 1x or an x. So since both of these equaled x, then we know for sure they are inverse functions. Let's take a look at another example. So in this one, similarly, we're going to look at this, and we want to find f of g of x first. So we need to put the g of x at x divided by 4 minus 3. And let's put that in place of x in our f equation. So when I do that, it's going to look like 4. And then in parentheses, all of this, x divided by 4 minus 3. And then we still have that plus 3. Now let's simplify what we can here. All right, let's distribute that 4 through so that we can simplify this. When I do that, I get 4x divided by 4 minus 12 and then plus 3. Well, let's keep simplifying here. I've got x, and then negative 12 plus 3 is negative 9. So I get that x equals negative 9, not just x. At this point, we could see these could not be inverses of each other if it doesn't equal x, but let's do the other way so we can see what happens there as well. So this time we'll take the 4x plus 3 and let's put it in place of x in the g function. So now we'll have 4x plus 3, all divided by 4, and then minus 3. Let's keep simplifying here. So this is saying both of these are being divided by 4, so let's rewrite it as 4x divided by 4 plus 3 divided by 4, and then minus 3. So we can see that our 4's divide out, and that's going to leave us x. But now if I have 3/4 minus 3, if I get a common denominator there of 4, I would have 3/4 minus 12/4. And then when I combine those together, I get x minus 9/4. So again, it doesn't simplify to be just x. So we can see that these are not inverse functions of each other, since they do not both equal x when we compose them.